Welcome, everyone, to the Simons Institute. My name is Sampath Kannan, and I'm the Associate Director here. For some of you, it might be the first visit to the Simons, especially on a topic like this, which we don't cover every day. So I thought I'd say a few words about the Institute. The Simons Institute was founded in 2012 by a generous grant from the Simons Foundation, and they continue to support us both through the Simons Foundation and the Simons Foundation International. Our primary mission is to have sustained programs that are semester-long that bring together, leading theoretical computer scientists in some specific area of theoretical computer science. But also, we have programs that look at other areas through the lens of theory. And we've had some very successful programs in physics, quantum computing is a big one, but also biology, economics, social sciences, and so on. So we're always excited to see where else theory can go. And this workshop is very much in that vein. We want to see this very important area of healthcare, privacy and other issues that require, and sharing data in the right way, and all that require a lot of theoretical computer science ideas. So we think this is a great and fertile area for the interaction between the two. We're very happy to finally have this workshop happen. It was long planned, long delayed because of circumstances beyond anyone's control. And so we're excited to see you all and hope you have a great workshop. And I will turn it over to Omer.
Hi. Thank you very much. So for theoretical computer scientists, this is home for us. And so we're very happy to have all of you in the home. So you should imagine me being Eitan Bachmat, because he's the real organizer. I mean, there is a big bunch here of people that have their names, but he really did everything and initiated it and had the vision. But he unfortunately couldn't make it. And I think he built a lot of time for us to talk and perhaps collaborate, and it can be a little bit more even than a workshop if we can take it further. And not to waste any more of Katrina's time, our introductions in our field are very, very short, the name and the title, so I'll do that. So Katrina from the Hebrew University is going to tell us about research on sensitive data. Thank you.
So it's a pleasure to get to kick off this workshop, and I apologize in advance. I'm going to kick it off on a depressing note. My talk is going to be bad news, bad news, bad news, bad news. There's good news at the end. Just hang on till the end. But I think there's sort of an obligation on the part of somebody who spends a lot of time thinking about privacy to open with the bad news. I know some of you have heard some of these stories before, but I think it's important to revisit them in this particular framing to get us all on the same page, to understand the challenges that we face when we want to work with sensitive data, so that we can better understand the opportunities and the tools that we do have, despite the fundamental challenges here. Okay, so to get us all on the same page here, the starting point for today's discussion is that most of the interesting computations that happen today are in some way or another computations, research that happen on individuals' potentially sensitive data. I mean, we're all on board with that because we're here to talk about medical data. I think we can agree much of that is sensitive, but it's not just medical research. It's questions like, how does TikTok decide what video to show you next? How do they decide what video to show you next? You wish you knew. What do you suspect is involved there?
They're optimizing for making me very angry.
Okay, they're optimizing to make Omer angry, and how do they know how to make Omer angry? They've been watching him very closely. They know exactly what gets his attention, what gets his goat, and they don't know just about him, and they're not basing the choices of what to show him just on his behavior, of course, but on all of our behavior. It's questions like, how do the ads that you see online get chosen? How do you get driving directions? How is it that ChatGPT works so well? All of these questions and more, a lot of the interesting things that we know how to do today, it's because of analyses on personal, potentially sensitive data. So what's the problem that we're going to be worried about today? It's the problem that some of that data really is sensitive. And we got to ask ourselves, how and when can we make responsible use of this data? I'm not claiming that TikTok's making responsible use of your data. So we're going to use medical data as our running example for today, but my little schematic of medical data does not look like the medical data that you guys know and love. I got lazy making my pretend medical data, so it doesn't have nearly enough columns and it doesn't have nearly enough rows, but you all know what you're going to carry in mind. So I'm going to think about a medical database intuitively as having lots and lots and lots of columns, measurements, visits, diagnoses, whatever it is, and lots of rows where the rows correspond to individuals. You know that the reality is more complicated in lots of ways, but let's use that as sort of our example to hold in mind. And we're thinking about researchers who potentially, through their affiliations, have access to incredibly rich medical data, and I would argue have a responsibility to make use of it to make the world a better place. Have a responsibility to make use of it to make new discoveries that are going to save lives. At the same time, they have a concern about how to use that data responsibly. What precautions should they take? So one thing you might want to do if you sit on an amazing resource like this is you might think about how can you share this resource with other researchers. So maybe you want to take that sensitive data and you want to somehow make it safe. You want to fuzz it. You want to somehow do something with it to create a version of it that you can hand out to other researchers. How do you do that? How do you know that you're okay? Or maybe you want to just do some research and you want to publish the results. Maybe you want to take that sensitive data and you want to release a bunch of different aggregates, trends, various things about the patients that appear in that. Is that always okay? Is that definitely okay? What kinds of privacy protections might we put in place if we wanted to do something like that? Or maybe you want to do something that sounds a little bit more abstract and sophisticated. You want to take that sensitive medical data and you want to use it to make complex decisions. Maybe you're going to use it as the basis for changing treatment protocols. Maybe you're going to use it to decide where we're going to place treatment centers for disease. Maybe you're going to use this to set public policy. All that sounds, very far removed from the underlying sensitive data, but is it in some way potentially revealing? Can it be problematic to make policy decisions on the basis of sensitive data? And how should we think about that? Or maybe you want to do just the simplest, most innocuous looking thing. You want to take that sensitive data and you want to release a single statistic. Surely this should be okay. But how do we decide what's okay? And what does okay mean? And how do we go about it? Now, you guys are the easy audience because you already are convinced that this data is out there, it's rich, it's important, it's sensitive. But I want to sort of provide for context just the perspective that is not just medical data that's sort of relevant to our discussion today. I picture each of us as we go through our lives sort of being followed by a cloud of data about us. This sort of follows us through our day-to-day. It's getting richer by the moment, and it's being used and collected by all sorts of entities, most of whom we've never even heard of. Of course, this is not an entirely new phenomenon. Those of us who are above a certain age, I won't ask you to reveal yourselves, remember when it looked like this. You used to get catalogs in the mail, and how would you get catalogs, tailored to your interests? It's because you bought some pet supplies, and so then your name and address were sold to companies that were interested in selling you more pet supplies, and so on and so forth. Also, for those of us above a certain age, your keychain used to look like that. What is that? I'm outing you. I know. I'm sorry. Does anybody know what this is?
Membership cards to all the different.
Yeah, membership cards to all the different things. But that's not gone. You have an equivalent. What's the equivalent today?
The app.
You have the app, or when you check out, they ask you your phone number. Why do they ask you your phone number when you check out? Are they just being friendly? Why do they want your phone number? It's a unique identifier. It allows them to tie your purchases at this moment today in this particular store to a world of other data about you. And sometimes they give you, $1 off for having given them your phone number. Is that because they're just really nice? No, it's because it's worth more than that $1 to have tied today's purchases in. But of course, in today's world, it gets richer, it gets more complicated. If you ever make purchases, say with a credit card, if you ever have any interactions with any government, if you ever receive health care, relevant for today, if you ever use the internet, you do searching online, you maybe use the internet to receive services like mail, maybe you buy things online, you get entertainment online, whatever it looks like. All of this contributes to this cloud that's following each and every one of us around through our day. And also, returning more to sort of the topic for today and for this week, that data could look like people participating in studies, filling out surveys. It could look like medical data of various sorts. It could look like administrative data. We have huge and rich sources of data. And I don't want to say that's all bad. It's incredibly powerful and incredibly good for discovery, for understanding how humans work, how humans decide, how humans act in the world. It's incredibly powerful for discovering when something new is happening. And it's the basis for all the cool stuff that we're seeing, like ChatGPT. So this incredibly rich data that's being gathered about all of us has a lot of power. And like I said at the beginning, I think we even have, in many cases, a responsibility to make use of this data. So I'm not here to say, don't use the data. Absolutely not, particularly in the medical context. We have a responsibility. The question is, how do we approach that responsibility responsibly? OK. As I promised, I'm going to be bad news, bad news, bad news for a while. I want to convince you that getting it right is hard. And I'll give some examples, some of which look like medical data, some of which don't look like medical data, to try to convince you of sort of what are some of the underlying challenges when we want to make use of this rich and potentially really impactful data. So for a starting point, we're trying to figure out what is it that we want to promise to individuals whose data shows up in that rich medical database. What's a reasonable form of a promise that we could give them? What are some things that we should legitimately be able to do with that rich database? And what are some things that are definitely not OK? Anybody comfortable sharing an example, a suggestion in either direction? Something that ought to be OK, or something that definitely sounds bad?
Definitely sounds bad. Release all their identifiers, address, sort of all of their raw details publicly.
Excellent. OK. I really like planting the flag, sort of in the extreme. Yeah. So it is probably bad to release everything about somebody, including all the identifiers, when we've got this rich, sensitive data. I'm with you. Yeah.
Pseudonymized genomic data, assuming that it will be privacy maintaining and finding out that at least in a third of the cases, they can easily track down the individual.
Fantastic. OK, so now we're getting into slightly more subtle situations. You said pseudo-anonymized, so with the suggestion that somebody maybe thought this was a good idea. Attempting to try, you're pointing to the fact that we can attempt to try to anonymize in various ways this rich data, and then we can sometimes get bitten by it. Great. Other places where you want to put down a flag of some sort as OK, not OK, yeah.
I think most people would like that you could guarantee that no one could learn anything about them personally, be it deterministic or probabilistic. Like, I wouldn't want someone to be able to say, listen, I know something about you that maybe you don't want to share with me.
That's great. I really like how you articulated this idea that as an individual who's considering whether to participate in a study or to allow my data to be used for some study, I would maybe like some promise to me about what can be learned about me. Yeah, and that's something that we'll explore today, to what extent we can give that kind of a promise and what that might look like. Yeah, any other flags anybody wants to place here?
So maybe something which is a common knowledge, so already known to the public, so maybe it's not a big problem or not a big issue. Probably it's, on some hand it's related to famous people. It's famous to some extent, so we know, I don't know, the age of the prime minister is probably okay, but it's also, I think there is some range where there are information, or there is information that is okay to share, or okay to be published, and other than not.
Yeah, so I think that this raises a really important perspective, that all of these things that we do with this sensitive data are against a backdrop of whatever else is already out there. And it can be difficult to know what else is already out there, but in some sense, you're saying, well, maybe what we should be concerned about is sort of the marginal harm, the sort of additional harm caused by our releases, given that all this other stuff is already out there in the world. And maybe there can be some way to reason about the sort of marginal harm of our study on the basis of, what is already known by the public. Yeah?
Maybe there's a way to put an effort tag on what is needed to create the identification. So if somebody would have a whole intelligence community work on this, whatever record that you have, and would be theoretically potentially identifiable, is different than just the average person on the street able to access the data and be able to kind of devise. So I think there's a spectrum of effort required to make the data identifiable.
Yeah, so this idea that potentially we have to reason somehow about the sort of motivation and powers of the attacker. And there can be different sort of models of attackers that might have more time, more money, more resources, more data, more compute on hand, like a motivated state actor, as opposed to, my neighbor who just happens to know some things about me. Yeah. So modeling attackers is really, really hard, but there is some sense in which there are a couple of very, very different scenarios that we might think about in these settings. Yeah. So you already alluded to this getting us into trouble, but let's just spend some time with anonymization or pseudo-anonymization, which I have trouble saying, but I'll persist. And sort of revisit some cases of this done with, very good intention, but gone wrong. So, various approaches to taking a data set and deleting the identifying information. So everybody who works in the privacy field has favorite, oldie but goodie kind of classic stories. So I'm going to share a couple of mine that are really old, and you're going to say, oh, but we're so much smarter today. That was decades ago. We would never do anything that looks like this today. Okay. So my first oldie but goodie is from August of 2006. Imagine yourself back in those days, if you existed back in those days. And it was the early days of internet search. Internet search was this cool, new, amazing thing that could find you stuff and could answer your questions. Sort of like the early days of ChatGPT. Like, whoa, this is really cool. And search was a thing that was not very well understood at the time. This was before Google was really the way to search things. At the time, if you wanted to search for something, you would have used AOL search. And so AOL had this amazing, amazing insight into search that really nobody else had. They knew what people were searching for, what was getting returned, what are the powers, what are the limitations, what's going on in this world. And they had a research arm that had really good intentions and wanted to try to share some of this perspective and insight with the research community. So actually timed with a major sort of information retrieval conference that summer, they did this really nice research release of data. So they released over 20 million search keywords paired with anonymized user IDs for over 500,000 users for a 3-month period. So they took search records, they anonymized them, and they released them to the research community. How'd that go for them?
When you say anonymized, do you mean deleted, identified information?
choice. They used the best tools that were available to them at the time. This was, well-intentioned, smart people, removing the obvious identifiers. If you can do a search on your favorite search engine for terms like AOL search debacle and get the whole story. Not surprisingly, this did not go well. It was 2 days before this is the headline story of the New York Times, a really nice story if you haven't read it, by the way. A re-identification of a particular woman in Georgia whose searches were not that embarrassing in the scheme of things, but not things that she thought that the world was watching. She had this impression that she was talking to a computer, and there weren't any humans looking over her shoulder. And then what? The whole world knows that her dog pees on everything, that she's looking for a romantic partner, that she's searching for medical information. Whoops. And it's not just her. Many people were re-identified. And of course, AOL research panicked, took the data down. I was just talking the other day to somebody who was there at the conference when the data was released, and he said, we were all handing the data set around on thumb drives because we knew it was going to be seconds before it was down. We all wanted to get it. And they knew this wasn't going to go well on some folks on the research side. But can you take a data set like that down? No. Any of you are interested? You can go, you can download it. There's some very interesting profiles in there. But, AOL research, basically shut their research branch. People were fired as a result of this whole debacle. You can't undo it. If your data was in that set, it's out there forevermore. How did this go so badly for them? I mean, they were smart people with good intentions. Now, they took my search history, and they deleted the identifying information. So first of all, they didn't associate my searches with my name. They replaced it with some, anonymized user ID. Maybe they even caught things like my last name here. But that's never going to let you figure out who anybody is now, is it?
I think the bed bugs are giving.
Good, yeah. So now it looks obvious to us that this is a dumb idea. And you would think nobody would try to release search logs today. They're just so rich, right? I mean, they have so many things that, my neighbor could know that I'm going to this workshop and, one other thing about me, and boom, it's easy to find me in this search data set. But actually, both in the US and in Europe, there is coming at us very fast legislation that is going to mandate publication of search records. Now, this is going to be not because, just because they like to break our privacy. It's because they want to break the monopoly power of Google and the big guys in this space. But watch for my nice example in my next talk. It's going to be a modern example. Okay, so one lesson to take from this is ad hoc solutions are risky. Another lesson to take is that maybe there's a big opportunity here for formalism. Okay, so we took on a really hard problem to start with. We took on this really rich data of search logs that has tons of hidden identifiers in it. Maybe, okay, this idea of trying to just delete identifying information is hard. Maybe we won't take that approach. But it turns out this is sort of an example of a broader phenomenon that Ron was alluding to. And we'll sort of spend a little bit of time with the underlying concern here. So the underlying concern is that identifiers in a sensitive data set could be linked to other data sets, where other data sets could be just the things my neighbor knows about me, to learn more about or to re-identify individuals. And the challenge here is, what's an identifier? What's the possible key to unlock, that this was me? In my search logs there, it was the name of this workshop and my research interests, which both appeared in my search logs. But how's somebody supposed to know in advance that that's going to be the thing that unlocks this? That's going to be the key. That's going to be the identifier. So Another example of this gone wrong, also a classic, is in a setting that feels a little bit closer to home, but also a little bit less obviously rich. So the search log's problematic. Let's take another example. This is an example from the 1990s when the Massachusetts Group Insurance Commission released data on individual hospital visits by state employees to aid research. So this is, again, an example of, this was not a hack. This is well-intentioned researchers using the best tools, anonymized a data set for good purposes. They wanted to aid medical research. So this is the state of Massachusetts. Basically, everybody who works for the state of Massachusetts receives their health care through their employment, and therefore the state holds records of hospital visits by all the state employees, including the governor. And the governor reassured people. The governor at the time, Bill Weld, assured employees that their data had been anonymized. They'd removed the obvious identifiers, the names, the addresses, the social security numbers. All that was obviously gone from the data set. So along comes a clever then MIT student, LaTanya Sweeney. And she knew the governor, lived in Cambridge, Massachusetts. Back to some information's public. And she purchased the full roll of voter registration records for Cambridge for $20. In the US, this is a standard sort of data source that's considered public information, who is registered to vote. So it's just lists of names with very little information about people, but a little bit of information. In particular, the database contained the name, address, zip code, birth date, and sex of the 54,000 registered voters in Cambridge. Doesn't sound very sensitive, right? It's like a pretty generic data. But only 6 people in Cambridge shared the governor's birth date, which was public information. Only 3 of them were men, and of them, only he lived in his zip code. So next thing that happens, she delivers the governor's medical records to his office. But this wasn't that she just got lucky. She then went and showed that actually at the time, 87% of all Americans were uniquely identified by the seemingly innocuous set of zip code, birth date, and sex. Uniquely. I've been actually trying to get a set of students to do a similar thing for Israel and for other countries, because I think we need this statistic to show that just a small handful of totally innocuous looking statistics, in many cases, uniquely identifies people. And that can be used to link to all sorts of potentially sensitive data sets. So we have lots and lots of examples of an anonymity gone wrong. You take rich data sets, you try to anonymize them, it tends to go badly. And it's hard to know what that outside information is going to be that's going to unlock things. It can be another data set, but it can just be, the comments that somebody made. You're taking a class, the grades are posted without any identifiers, but it happens to be that you sat next to somebody who said something like, I'm finally getting the hang of this, my grade on homework 2 was 10 points higher than on homework 1, and they only missed 2 classes this semester. Because you sit next to them. What's their final grade?
60.
Yeah. Whoops. So how are they supposed to know that was going to be the thing that was going to identify them? So theme, we don't know what that signature is going to look like. It's just incredibly hard to know. And so anonymization is an incredibly daunting task. Because somehow you're supposed to fuzz all the potential signatures that could be used to link people. OK, so in the literature, sort of the response that came to this realization that people were being uniquely identified in these supposedly anonymized data sets, and this was being used to discover who they were, the response was to say, well, let's not let people be unique in data sets. After we do some process on the data set, let's ensure that there's no row that is unique. And then I won't be able to link you up. I won't know who you are. I can't know who you are. And this is sort of a cluster of approaches that get known as k-anonymity. You can already see from the title here what I feel about it. But we'll spend a little bit of time with it, because it's being used right now to protect your sensitive data. So we might take a data set, and in order to preserve k-anonymity, in order to ensure that no row is unique, what we might do is we might coarsen the data in various ways. So maybe we remove the sort of most geographically specific digit from the zip codes. Maybe we remove gender from some of the entries. Maybe we bucket the ages or even remove some of the ages. We do various things in order to ensure that there's no, there's no unique row. And the k in k-anonymity is how many identical rows should there be. So if k is 5, there have to be at least 5 identical rows. Okay, so but if I know that you live, I know that my neighbor is a guy who lives in 98987, he's in his mid-50s, and I know he's in the data set, that didn't help him so much. Okay, what do I know about him? Oh, for those of you who are poorly positioned, either you have a screen there or you can move yourself so I'm not blocking your view. So what do I know about my neighbor? He's got lung cancer. Okay, so clearly we did something silly here, right? We made all the rows have duplicates, but that meant, okay, I don't know which row he is, but I learned something embarrassing about him. So maybe what I need is to say that, okay, there's no unique row on the sort of identifier columns, but maybe the embarrassing secret column, the disease, should have some diversity to it. There should be multiple values there. So maybe a data set like this would be fine. How does my neighbor feel about that? Okay, I don't know which cancer he has, so maybe that's progress. But you can see this is sort of this cat and mouse game, which is basically what this field has been doing, is coming up with suggestions for what we can do to data sets and then realizing, whoops, that didn't work. And we persist in doing this. K-anonymity is broken in all sorts of rich and interesting ways. I'm not going to spend a huge amount of time on them, but you should know that the number of ways in which it does not provide privacy is astounding. It can often actually be undone. So if I know that you've coarsened a data set sort of until the point at which you achieved your anonymity goal, the fact that you reached a particular point tells me something about the richness that was previously present in the data. And so I can actually roll back some of the steps that you did, which can be revealing. And then it also has the interesting property that I can do something that's k-anonymous over here, 3 anonymous. I can do something else over here that's, I guess this example is 4 anonymous and 6 anonymous. But the combination of the 2 data sets can have no k-anonymity guarantee whatsoever. So in this example, if Alice's employer knows that she's 28 years old, she lives in zip code 13012, and she visited both of these hospitals, he actually learns her sensitive condition. So doing something that's k-anonymous, something else is k-anonymous, maybe it was another research team that did something that was k-anonymous over there, so I don't even know that they did it. Whoops, the combination just breaks the guarantee entirely. It also, when it's used in practice by the people who are most proud of their skill set in this regard, in this case, there was a data set of edX data. So edX is one of these sort of massive online course platforms, sort of with all the data of everything that people on the platform did, where they clicked, what they tried, the questions they got right, the questions that they got wrong, their performance, and all the exams, the courses, everything. So there's an amazing, rich learning data set. And so researchers at MIT and Harvard can anonymize this data set very carefully, released it for researchers, and again, another troublesome graduate student, in this case, Saloni Cohen, comes along and, whoops, de-anonymizes it. In this case, what's the sensitive thing that gets revealed? So it turns out people very proudly put on their CVs and their LinkedIn the courses that they passed on edX. They don't proudly announce the courses that they failed. And so he was able to recover this information about a good number of people. Okay, so maybe we were just trying too hard here. We were trying something really hard. In all of this, we were trying to take incredibly rich, sometimes very sensitive data and make it safe somehow. And we were trying to release something that looked like data. So maybe we should set our sights on something a little bit more modest. Maybe we could say, what if we just want to release some statistics? Surely this should be OK, right? We want to release benign questions that pertain to large populations. So to convince you that this is maybe not quite as safe as this looks, imagine that we have this nice room of people, but imagine the auditorium were really full. Every seat is taken here. We've got a good number of people in the room. And I'm giving a lecture. I say, OK, let's do something interesting. We want to find out what fraction of people in the room have a particular embarrassing trait. Maybe let's say, what fraction of people in the room have ever cheated on a romantic partner? Now, it turns out, if I go around and ask you one by one, have you ever cheated on a romantic partner? Nobody cheats. It's amazing. So I want to elicit this information in a way that maybe gives you some privacy. So instead, I'm going to have you write yes or no on a piece of paper. I'm going to put this in a big bag, stir it around, and then I'm going to give it to Omer and give him the really fun task of counting all the yeses and all the nos. And so Omer is going to spend the rest of my lecture counting little slips of papers, and then he's going to write on the board, not quite the rest of my lecture, and it's a, he's going to write some numbers here. Okay? And then somebody comes in late, because that always happens. And he doesn't know what those numbers mean. And I say, hey, everybody, let's do a fun experiment. Let's find out what fraction of people in the room have ever cheated on a romantic partner. You're each going to write yes or no on a piece of paper. We're going to put them in a big bag. We're going to stir them up. I'm going to give them to Omer again. Sorry. And he's going to count and count and count. And then he's going to write some numbers on the board. Opa. What just happened there? Aggregate statistics, large population. This could happen if I did 10,000 people.
I've just entered the room.
You just entered the room. So what happened? Aggregate statistics, totally fine, right? What went wrong? Well, you're thinking, OK, this is a silly example. Why is she giving me a hard time about a silly example? Nobody does a statistic on a large population and then that population plus one poor person. That is not a thing we do. This is obviously some bizarre edge case that I don't need to worry about. This is not for real. But it's a hint of an underlying phenomenon which is real and that we do have to worry about. So let's move to a totally different scale of problem. Let's talk about the US Census. Every 10 years, the US is obligated to collect information about every single person who lives in the United States. And up until recently, this meant sort of going door to door and knocking on every door, coming back and knocking on your door again, coming back and knocking on your door again until somebody answers the door and fills out the survey. These days, they use a mix of ways of getting to every single household, but they are obligated to get to every single household because the data that they gather is incredibly important. This is how we understand the US population. This is the basis of basically all research on the US population, and it's also the basis of important decisions about how we allocate a lot of stuff. How we allocate votes, how we allocate money, all sorts of things is on the basis of who lives where and their properties. So the US is obligated to run the census every 10 years. Other countries have something similar, so feel free to use your national example in your head. The US is prohibited, simultaneously the census is prohibited from releasing any information for which the data furnished by any particular establishment or individual can be identified. So they gotta gather the data, and they got to make a lot of statistics about it public so that people can do stuff with it. They also have an obligation to privacy. To give you a sense of the scale, in 2010, the census covered 308 million people, and 7.8 billion statistics about that population were released as part of the census. That's a lot of statistics. OK. The census is very aware of privacy and has some of the best statisticians around. Historically, up through 2010, what did the census do to protect privacy? Well, it's a secret. It's only a handful of people in the world know secret. We have to make inferences about this, like, if I tell you I have to kill you kind of secret almost. But we infer that it's some combination of, known techniques that look like swapping, masking outliers. Basically, the toolkit that we've got for trying to hide people in a data set. But it's a big data set, millions and millions and millions of people. But at some point, the census started to get nervous, and so they did something interesting. When they got nervous about privacy, they decided to attack themselves. So the census ran its own reconstruction attack on those 2010 census releases. What's the idea? They gave a team access to all the billions of statistics that had been released about the 2010 census and said, here, see what you can do with that. Your task is to try to reconstruct the underlying data. How would you do something like that? Well, intuitively, each of those statistics that was released is sort of a constraint on what the data could have been or what it could not have been. When I know that there are 3,567 men with a particular age range in a particular geographic region, that means the data couldn't have been data where there were 5,000 men with those properties in that range. And that crosses off a bunch of potential data sets. So every statistic is in some sense crossing off a bunch of potential imaginary data sets that could not have generated this data. So even if you know there's some noise in the census statistics, you still learn a lot from every additional statistic. It's sort of peeling off the space of possible data sets. So what did they do? They did that process. And then they took it another step. So in addition to trying to reconstruct the rows that were the information gathered as the census, they acquired some publicly available data and used that to link those rows to names. And because they're the census, then they could check and see how they did. And they did pretty well. Or pretty badly, depending on your perspective. There are various ways to interpret this attack, so don't get too attached to the numbers. And there's sort of a there's some conservatism in the approach that they take here, but they had confirmed re-identifications of 17% of the US population. Now remember, it was illegal for them to release statistics that would allow any one person to be re-identified, and they just allowed millions upon millions of people to be re-identified. And they also correctly reconstructed the block, sex, age, race, and ethnicity, and where age is up to 1 year, so they could be off by plus minus 1 year on 71% of the population. Okay. But the census is releasing these really boring-looking statistics. These are aggregates. These are how many people with these properties live in the state of Montana. So how did that get them in so much trouble? How are they reconstructing 71% of the data set? It's exactly what I was saying before. It's this idea that every single aggregate statistic that you release is a constraint on the underlying data that could have generated it. And without any noise on these constraints, this actually very, very quickly allows you to reconstruct the underlying data set. And even if there's noise on the constraints, it's still information. It still allows you to make progress on reconstruction. And there's something fundamental and unavoidable here. Too many too accurate statistics will allow reconstruction of the underlying data, period. This is unavoidable. This is not, depending on your notion of privacy. This is not, making any sorts of assumption. This is just the way it is. And so we have to know that if we care about not having the underlying data reconstructed, there's going to be a limit to how many reasonably accurate aggregate statistics we can release. Okay. So what are we supposed to do with our data? We had trouble with anonymizing it and releasing something that looked like data. We had trouble even with aggregate statistics. So what are we supposed to be able to do? And I want to get back to a suggestion that emerged at the beginning. Okay, so these aggregate statistics, maybe that's not enough. So what are we supposed to do? maybe we can somehow say something to individuals about what is or isn't learned about them, like we were sort of suggesting before. Maybe we could somehow make a promise that access to the output of our computations shouldn't enable anybody to learn much more about anybody in that data set than we could have learned about them if they hadn't been in the data set. Now, it's kind of a mouthful. It's kind of hard to parse. Doesn't look like the kinds of things we were trying to promise before. But maybe this is the start of something that we can make use of. If we can promise you that even if you participate in my study, even if you're in my data set, that the studies that I do aren't going to teach the world much more about you than they would have learned about you had you not even been in the data set. Maybe that's something. I wouldn't say it's definitely satisfying, but it's maybe promising. So this is the notion that underlies the formal mathematical notion that gets known as differential privacy. It's a notion invented by Dwork, McSherry, and Seaman Smith in 2006. The sort of ground was laid in the couple of years leading up to then by a couple of other papers. But the intuition here is that maybe a notion of privacy that can be useful is a guarantee that restricts our algorithms, our things that we do with our data, our computations that we do, our models that we train, our statistics that we output, that constrains them to say that when they get similar data in, they should produce similar results. And the idea here is that if we could get a guarantee like this, then it might mean for the individuals who are thinking about whether or not it's OK for them to participate in the study, it could mean that my data can't affect the outcome very much, because you would have gotten about the same findings, about the same results, about the same models, whatever it is, even if I hadn't been present in the data set. And so intuitively, any attacker or curious person or neighbor or whoever it is who's looking at the results of this computation can't learn very much about me specifically. They might learn stuff about the world. They might learn that smoking is correlated with cancer, but they're not going to learn a lot about me from me being in the data set. And the goal is to somehow get this kind of a guarantee while still being able to do something useful, while still being able to learn that smoking is correlated with cancer or whatever rich thing it is that you want to discover in your data set. So a little bit more formally, the flavor of the guarantee is that for any two databases that are identical sets of rows except for the addition or removal of a single person's data, so just think of the data set of all of you guys versus the data set of all of you guys plus me, we want our algorithm to be constrained in how it behaves so that for any possible thing that it might produce, whether that's a trained model or a set of statistics or some synthetic data, whatever it produces, it had to have almost the same probability of producing that thing, regardless of whether we were in the world without me or the world with me. So this algorithm has to be, in some sense, kind of stable to my presence or absence. The algorithm can't be very, sensitive to whether or not I'm there in the data. And we can formalize this in a particular way. But the formalism is maybe less the point here, and maybe the intuition is the main thing that I want to get across, because this is the basis of now 20 years of research. This is a notion that really has taken off in the theoretical computer science literature. It's also taken off in the sense that if you're carrying an iPhone in your pocket or a Pixel phone in your pocket, it's being used to protect your data right now. And the intuition here is exactly this intuition that the distributions that we induce over possible outcomes should be nearly the same, regardless of the presence or absence of any one person or handful of people's data. In some sense, it says to you that so you might as well participate in my study, because you're not having a serious impact on things. It has lots of really nice properties. It doesn't get us into the business of trying to model the adversary and think about their computational abilities and what outside data that they have. It's got lots of nice mathematical properties that I won't spend time on, but you should know that they're there, and we'd love to talk about them. But you should know that it's being used to protect your data. And it's also what got used in the subsequent US Census to try to protect census data. So I want to give you a very sort of quick overview. This is supposed to be the positive part of the talk. Hopefully I depressed you sufficiently. A little.
The census right now, I can only question it through the lens of differential privacy?
So all releases on the basis of the 2020 census were made with guarantees of differential privacy. So they, again, released a huge amount of statistics, but with a differential privacy guarantee. Not a very strong differential privacy guarantee, and there's a lot to discuss about sort of the nuances and how to interpret the guarantee. But I think it's sort of a step in the right direction in terms of awareness and in terms of deployment of the relevant mathematical toolkit. Okay. Oh, pardon.
Sorry, yeah, so, implicit in a lot of this, and I see why it's beneficial computationally, but is the notion that we are not conditioning on what other data might be available publicly or what people otherwise could know. But it seems to me that, if I can recover something that I could have learned without this data, then it doesn't really affect the risk, right, to the individual. And in a lot of cases, especially now, there are lots of data that are available publicly, even about individuals. To what extent does that change this picture, or should it, or?
Yeah, great. So sort of two pieces to the answer, maybe. So this is a question that says sort of, this is a definition that's sort of agnostic to like what other data is present out there in the world. It makes no assumptions about what data is or isn't present. And it just talks about sort of the marginal privacy harm if we do the study with you versus without you. So on the one hand, it's a major strength of the notion that you don't have to do any modeling of what outside data an attacker might have. But if you do have some outside data that's already out there, for example, I have last year's statistics that were revealed, and now I want to reveal this year's statistics, you can use that to get better privacy accuracy guarantees under this notion. So for example, whatever algorithm I'm going to use in order to generate this year's statistics, maybe I use last year's statistics as a starting point. And if it turns out they're very similar to this year's statistics, I can get a benefit. I can get sort of a boost in terms of the sort of privacy accuracy trade-off. And that's, I think, a really rich and promising direction where there's still room to do some work, is how do you leverage sort of outside data sources in order to get better guarantees. But you're still going to have the sort of worst case guarantee that even if you got unlucky and it turns out last year's data isn't all that useful for this year, you're still going to get your privacy. You might just get worse accuracy, which is, I think, kind of a nice way to sort of face these trade-offs. But absolutely, that's a really important and promising direction. I think there's room to do more there.
Sorry, just to expand on. So that makes a lot of sense. Does this apply in some sense in the opposite direction as well, in the sense that like at one point in time I was transferring my medical records and I called the old sort of office and they said, I said, oh, like, do you need my social or my, ID? And they're like, oh, just tell us your last name and birth date and where you want, an email address where you want your record sent, and we'll send it, sort of a thing, right? Mm-hmm. So implicitly, they were relying only on publicly available or very readily available data, right? So some aspects, and not just that's a good thing, to be clear, right? But some aspects of the data that could be released seem like maybe we should care less about them getting released because they're already available externally, and others we care much more. And could we, is that something that we should be modeling to say, oh, we can spend more of our privacy effort here on these things and less on this or something? Yeah,
I think it's a great point. So the definition as I presented it to you is kind of, it doesn't distinguish between sort of more sensitive data and less sensitive data. It doesn't give a language for talking about, this is my medical data, this is my location data, and this is what I ate yesterday. And maybe, maybe I want different privacy guarantees for each of them. It gives us a tool where we can talk about setting a different privacy level or allocating more of our privacy sort of budget to one of these things versus another. But there's sort of a gap in that we don't know how to sort of reason mathematically about this being more sensitive and that being less sensitive. That's sort of a human perspective that needs to be injected in the process. Yeah.
Yeah, so you said that for the previous census data, they had hired a team to try to re-identify. Have they done that for the DP protected?
That's a great question that I don't know the answer to. I've seen some sort of partial attempts, but I don't know for sure what to say to that. It's a good question. So we'll say a few things. First of all, I kind of was down on anonymization, but I don't think it's useless. Anonymization definitely has a role, but let's not think of it as, a surefire protection when we, put data out there in the public. Let's instead think about it as an additional layer of protection. Let's think about it as a way to minimize accidental re-identification by, trusted researchers who just don't want to accidentally see their neighbor in the data set. It's great for that. I mentioned differential privacy. As I mentioned also, there's sort of 20 years of research basically thinking about lots of things you might want to do with data and try to figure out how you can do them in a differentially private fashion. So how you can achieve good privacy accuracy trade-offs for lots of sorts of computations. And the way the algorithms work looks like sometimes we fuzz the data, sometimes we fuzz the algorithm, sometimes we run the sort of standard algorithm, and then we fuzz the results. Sometimes we do things that look like none of the above. So there's a really rich vocabulary at this point of techniques for achieving these kinds of guarantees, and we have a pretty good understanding for lots of things you might want to do with data about sort of what privacy accuracy guarantees are achievable. I'll skip through the concrete examples. I'll say we know lots of things pretty well. We understand how to give privacy under various models. We know how to release lots of aggregate statistics. We know how to train machine learning models with guarantees of differential privacy. And think about it. That sounds like a big, wild task. But what I said is differential privacy is sort of a stability guarantee. It says that the machine learning model that you get out shouldn't be very sensitive to the presence or absence of a particular person in the data set. But that kind of sounds like good science. And it sounds kind of compatible. Like we should want our training processes, ideally, to be somewhat robust. This robustness has lots of other things that are beneficial. Like, I could give you many hours of a talk about sort of robustness interpretations of the mathematical toolkit here. Turns out it's related to statistical validity and all sorts of other things you might care about, even if you don't care at all about privacy. We know how to answer requests formulated over time by various actors, even if those requests are adaptive. We know how to create synthetic data that respects key aggregates. So we know how to take your data set and produce something that you can publish, and you can publish it once and for all. And then you can go home and you can sleep well at night. Because nobody, unless they're going to peek at the original data, can degrade the privacy guarantees of what you've done. No matter how smart they are, no matter how many computations they run on that synthetic data, no matter how great their compute power is, no matter what access to outside data they have, what you've done has a privacy guarantee. You can go sleep well at night, and people can use it for all sorts of things forevermore. We know how to give guarantees where individual data providers provide their own privacy. So we have lots of models, lots of types of results that we know how to handle in these kinds of settings. Briefly, sort of as a summary, I want to make a distinction between sort of two kinds of problems that naturally get kind of entangled in our minds. And these are security problems and privacy problems. To me, security is about making sure that people don't get access to data they shouldn't have gotten access to. It's a really important question. And so we have interesting work and vocabulary in the field for talking about these kinds of things. We want to do things like trusted sharing. Maybe we want to use cryptographic tools here to allow joint computations so we can compute together on your hospital's data set and my hospital's data set. But even if you do all of the security stuff right, we could jointly compute something that's still problematic for privacy. So solving the security problem does not solve the privacy problem. It's a different set of concerns. The privacy world is questions about if I'm intentionally releasing something about my data set, I'm training a model, I'm making a policy decision, something that depends on the data, what does that thing I release reveal about the underlying data, and can I control the risk that's there? So if you want to release one or many statistics, we know how to do this with noise perturbation. If you want to release stuff that looks really, really rich, this is hard. Not that nobody's thought about it, but the tools are more limited. But if you want to do things that look like, training a machine learning model, or releasing synthetic data, or releasing statistics, we've got you pretty reasonably well covered in terms of a mathematical vocabulary. So for me, the main sort of takeaways from spending more time than I'd like to admit thinking about these kinds of issues are the following. One, anonymity, maybe not. Let's not rely on it. Once you release something, you can't take it back. So this is a space where we have to get things right the first time. We should be very paranoid. Any meaningful release or action based, with an S in it, on sensitive data is a privacy leak. Anything you do with sensitive data is a privacy leak, period. It teaches us something more about the underlying data. And those privacy leaks inevitably add up. But harms can be controlled. If you want to release something that's not very robust to small changes in the set of participants, ask yourself why you're doing something that's so not robust. And is it really good science? I think the sort of the toolkit and lens of thinking about privacy is really powerful, even if you don't really care about privacy for privacy's sake. I will leave us there. And we had great questions along the way, but if there's another one, yeah.
So, brilliant talk. Really, I enjoyed it so much. But I'm trying to reconcile it with the world as I know. So I'm a physician. I do a lot of research on private individual information. And the current standard in Israel, as you well know, is k-anonymity. And then I'm looking at what you said about differential privacy, and it sounds a lot more mature than I know. So why isn't the Israeli Ministry of Health mandating differential private data? If we can generate synthetic DP data, haven't we solved the problem? Like, why do I still get to look at k-anonymous data? Maybe I'm a malicious actor. I don't know. So is it better than I always thought? Because I teach my students that it's not there yet. Is it there yet?
It's a great question. So I think there are a few pieces to that. So why are you, as a physician, looking at k-anonymized data? Well, maybe because this is a setting where you are not a malicious actor, and we know that. And maybe actually, if we didn't have k-anonymity, we would have just given you the data set, without any anonymization. And k-anonymity is serving as a screen to avoid you accidentally seeing your neighbor in the data set. Maybe it's actually totally suitable. The situations that you're thinking about, where you're getting access to very sensitive data to do research, but we know who you are, and you've signed away your life, and you know that your career is going to be over if you use this data to blackmail your neighbor. And we know you and trust you. So maybe it's okay that k-anonymity is being deployed in this context. You asked, is DP actually sort of, mature and ready to go? So there are a few gaps that are still very present and that need work. And I think that they will maybe get the push that they need from partnerships between people who have real problems and people who think about the math in a very abstract way. So most of the people who work on differential privacy are theoretical computer scientists who don't know anything about real data and about the real world. And this results in a number of important gaps. One of them is we often sort of get asymptotic results, then don't pay attention to the constants, and then we don't realize that something that works well in theory, sort of kicks in and is reasonable when you have massive data sets, but maybe it's less practical for small data sets. And maybe it's not that we couldn't have thought about how to improve things for smaller data sets, but nobody bothered. Some of it is that this is a very worst case notion of privacy. And so often the amount of noise that's dictated by differential privacy in order to get what seems to be a reasonable privacy parameter looks like a lot of noise. And we don't yet have sort of a rich enough vocabulary for reasoning about, but maybe we're not really in that worst case situation, and maybe we can interpret the privacy guarantees as being much better than they really are. So I think there are gaps. I think there are real practical gaps. But I think what we absolutely need is people with real data and real problems working with people who come with this maybe not quite ready theory to figure out how to bridge those gaps. Thanks. I saw you first. Yeah.
So about the synthetic data, somewhat connected to Noam's question, if I understand correctly what you said, the current state of the art is that you can generate synthetic data, but you sort of need to know which aggregated properly you keep ahead of time. But in medical research, my understanding is that these are the stuff you need to find out. So like if you would have known ahead of time what are the aggregated properties you need, you'd need to do the medical research.
So this is a great point. Yeah, so thanks for pulling this out. Absolutely. In order to generate synthetic data, you need to anticipate in advance what properties of the data set you want to maintain in your synthetic data. And this is unavoidable because it is mathematically, fundamentally impossible to create private synthetic data that maintains all of the properties of the underlying data. I know there's some people who are trying to sell you this. They're lying to you. Sorry.
It's in every hospital.
I know, they already sold it to you. They're lying. It's fundamentally mathematically impossible. So yes, so what is the synthetic data good for? It might be that what we need to do is we need to do a few differentially private initial queries on the data set in order to figure out what's interesting, and then we create the synthetic data. Or maybe we want to use some of our privacy budget to create synthetic data to do some exploration, and then we realize, hold on, we didn't preserve some things that we really, really care about. We're glad we saved some privacy budget so we can do a fresh version of the synthetic data. There's going to be some adaptive process, and I think most interesting sort of scientific lines of inquiry have multiple rounds to them, and you have to account for this somehow. But it's a very, very important point that you can't preserve everything.
So that was actually my question as well, but then you answered it. Now I have a second question. So when you say, but we're not actually trying to preserve everything, right? Like, you know, I could ask for the set of functions that you could approximate with a differentially private algorithm, and that may be a subset of all possible functions I could apply to a data set. So when you say it's mathematically impossible, is that saying you can't preserve everything while preserving differential privacy, or is that saying that you can't learn the set of, you can't preserve the set of all functions that could be learned in a differentially private manner? Or am I missing something more fundamental?
So the statement that you can't preserve everything is actually not related to differential privacy. It's a fundamental truth that you can't preserve all possible statistics about the underlying data set without it basically allowing a full reconstruction of the underlying data set. That doesn't have to do with the differential privacy or not. But you're right that we don't really care about everything. And if you come and you say, look, you know, basically I think if I can preserve all the three-way marginals in my data set, that's a pretty good start. Great, we can do that. But then if you later come and you say, well, like there was this complicated other function that turns out is really interesting, we won't necessarily have preserved it.
So it's not necessarily, is it known to be the case that you can't make a synthetic data set that will approximate this, that will have basically the same approximate output for any differentially private preserving algorithm applied to that data set?
I think I didn't fully parse the sequence of things.
I'll
So maybe we
go
should
for it,
continue because I think I'm out of time. We can continue over coffee. Thank you all.
So it's 20 minutes, and in my first act of rebellion against Eitan, I think that when you come back, perhaps even before Michal's talk, we can have